Okay, so I am solving problem number 8, which is a certain substance has a dielectric constant of 2.8 and a dielectric strength of 18.0 millivolts per meters. If it is used as the dielectric material in a parallel plate capacitor, what minimum area should the plates of the capacitor have to obtain a capacitance of 5 times 10 to the negative 8 farads, and to ensure that the capacitor will be able to withstand a potential difference of 5.2 kilovolts? So first, we have K, which is the dielectric constant, which is 2.8. The problem also gives us the dielectric strength, which is the maximum electric field that this capacitance can reach before going into electrical breakdown. So that is E, and that is 18.0 millivolts per meter, which I'm just going to go ahead and convert to 18 times 10 to the 6 volts per meter. We're looking for A when the capacitance, which is C, is 5 times 10 to the negative 8 farads, and to ensure that the potential difference, which is V, will be 5.2 kilovolts, which I'm also just going to go ahead and convert to 5,200 volts. So first, we have an equation for a parallel plate capacitor with a dielectric, and that's given to us in the form C equals K epsilon naught A all over D. And we have K and epsilon naught, which is just a constant, and we also have C. So we can go ahead and solve this equation in terms of A and D. So that means that A over D will equal C over K epsilon naught. And now just plugging in, we have 5 times 10 to the negative 8 over 2.8 times 8.85 times 10 to the negative 12, which, like I said, this epsilon naught value is just a constant. And whenever we do this problem, we get that A over D equals 2018. So now we can solve D, or for D. So D equals A over 2018. So we also know that the potential difference is equal to the electric field times D, because that's just the separation between the parallel plate capacitors. So we know that potential difference, which is V, is equal to electric field times D. And we have V and E, so we can solve this equation for D. So solving for D, we have D equals V over E. And now just plugging in V and E, we have 5,200 volts divided by 18 times 10 to the 6th volts per meter, which gives us a D value of 0.00028889 meters. And now we can plug this D value back into this D equals A over 2018 equation. So we have 0.00028889 equals A over 2018. And now we can go ahead and solve for A. So A equals 2018 times 0.00028889. So A ends up equaling 0.583 meters squared. And that is the final answer.